My name is Greg Makowski. I've been deploying data mining since '92. This was one of the projects I'd worked on at JDA Software. It was an enterprise retail software vendor. So they had about 50 enterprise products. So rather than Microsoft Word or Excel for a consumer, these would be products that the entire enterprise would run, like one copy of to handle some large part of their business. So that's the overall context of what this was. So it was a couple-year project. And so this was working with some of the customers and clients on kind of a hybrid consulting and software development that resulted in the enterprise software. So in this, the particular problem I was working on is how to automate not just the forecasting, but the model training. So a lot of times you can be a data mining consultant, come into a project, train a predictive model, put it into production, sure, that's fine. But how do you automate that process? How do you put the data mining consultant in a box, so to speak? And so part of the solution was focusing on a narrow vertical market application. So it couldn't be tied specifically to data field names, but the types of fields you were working with were things in the retail supply chain. It wasn't things like stellar data. I'm not trying to generalize that broadly, so have some kind of domain focus. And so the result was an enterprise application called ELF, Event Lift Forecasting. And we had up to a 30% reduction in the dollars lost due to over and under stock. So to talk about what the project was and where it fit in is JDA Software had lots of these enterprise applications. One of them was replenishment. And replenishment would be something that as you sell off the shelf, you keep it resupplied. So as you're moving the goods from the warehouse to the distribution center to the store, then the challenge is how do you minimize overstock and understock? And so that would work very well in a steady state system. That was an application that had been going for 10, 20 years just to do the replenishment. So for things, basics like white socks or milk or very generic things that are very predictable in their sales, then that would work very well. But where the pain point was is when they have sales or promotions, then it would be harder to predict. The particular application was sales. So if you would have promotions, so this was dealing with weekly flyers that might come in your Sunday newspaper. So that might be like from a Walgreens or CVS or a drugstore. And so they might be promoting 1 to 4,000 items or SKUs, stock keeping units. So sometimes it might have a half page that could have several dozen. And so for that particular problem, then they had category managers. So one category manager might be managing, say, just things like backpacks, school supplies, office supplies. Another category manager might be handling drinks and beverages. And so those people would be responsible for both planning the promotions and also estimating what the outcome of the promotions would be. And that would be a pain point because every planner would have to estimate the lift in sales for every store item combination. So the Palo Alto Walgreens that's on El Camino and the East Palo Alto Walgreens somewhere else. And so for all of the different store locations and all the different particular items. So if you think of something like Walgreens where there's 6,000 stores and you think of 1 to 4,000 items per store, then that's needing up to 24 million store item combinations where you have to come up with a different lift estimate for each one. So that's kind of the pain point, probably trying to solve that, going from human estimated to something that would have a data mining model. And so here in the drinks category, you can see the different sodas. So there might have one kind of pricing promotion here for that particular location. So a lot of the factors that would affect it would be the size of where it was placed in the ad. Is it on the front page? That would have a much higher lift, or the centerfold would have the next highest lift, or the back page would have a high lift. But if it's somewhere in the middle pages, if it's promoted on something that's a top half of the page, then those items would tend to have a higher lift than something else. So there's all these different factors that affect the marketing placement as well as the product and the product attributes and the pricing, how much was it discounted. And so then these promotions or layouts could vary by region or zip code. So it's not just one marketing promotion going out nationwide for that particular Sunday. It could be dozens or hundreds. So the project was called Event Lift Forecasting, or ELF. So we were going from one application, the event planning, that does a flyer layout. And so what items do I put for sale and retail on this top right page and the top right corner here, and just doing all that layout. So that would be something that a category manager would use, and it was like a visual application. So again, a person that can spell Excel, but I don't expect them to spell statistics or data mining. And so the person that does this event planning might happen maybe 3 weeks before the event, it's not planned out way far in advance, like 6 months, but it's in a shorter time period. On the bottom left, the event planning flyer would feed into the new module, the event lift forecasting, and then that would feed into the replenishment. And so that was like the overall flow of things. And so it's trying to talk about product X in store Y will sell 6.8 times higher than normal. And so that would be some of the context of trying to work on this project. So the retail event planner, they would have revenue goals and a budget for how much they can discount. So fewer items with a heavier discount, or more items at a smaller discount. So those are all the latitude that they have. They have to get through a lot of detail quickly. And so this is much more of a how to assist the person, much more of a design of manage by exception, where things are unusual. So it's very much trying to help a non-technical person with all the automated data mining in the background. So using the enterprise application to lay out the event flyer about 3 weeks in advance, I mentioned that. And so they're looking at, there would be a retail hierarchy, like a departments, items, or a department, sub-department, category, subcategory, and then the particular SKU would be the different levels of granularity. So the software would be working more at the SKU level or the subcategory level. And just a general intention is try and build in DWIM, do what I mean. So to have the software function as you'd like it to, and not have to worry about it. So how to productize. So again, because it's not a one-off consulting project, but software, so we had to gradually get into the ballpark. So we had made arrangements with a couple of software development partners. It was kind of a cross between consulting and software development. So I had deliverables for the two different retail clients, but what I was focusing on is what's the 80% overlap? What are the common cases that would be needed across all retailers? So whether it's something like a Home Depot or a men's clothing store or Gap or anything like that. So I want to try and be general for handling promotions and replenishment. So we wanted to have at least 90% software, and we could allow some amount of configuration. So with a lot of these large enterprise software projects, an install could take a year, and the software sometimes could be $1 million or $5 million for a large company, and it could have maybe an equal amount of software consulting for the install. But for this, we wanted to have the install be much more of a configuration and not a data mining project. So it was much more of the configuration is how do we map this database schema to the different metadata fields. So, okay, we don't know how you spell zip code, but we have various geography partitions, and we have a metadata tag for that. And we have something for cost. And so then all the models would work on these metadata handles. And that's how it would generalize going installed from one place to another. And it would be feeding in our replenishment software, but that wasn't a requirement. We could sell ELF standalone, and it could feed somebody else's replenishment software. Or they could be using our event layout software or somebody else's. So during the installation of ELF, part of the design was, we have to have the mapping. So we have a consistent data flow. And so part of it was looking at what's the total cost of ownership for the product. So there's the software cost and then the consulting cost to get it going. And so our bias was just be competitive, lower it overall for the customer. How can we reduce the total cost of ownership and maximize the value for them? And also it had to be very reliable when used by a business user. So if you give something to people in a data mining class and the model's not so general, it doesn't hurt so much. If we have something that even in a simple situation causes a lot of dollars to be lost, something that could cause somebody to be fired would also cause our software to get kicked out. So there's reliability has a much higher issue in this environment than if you're just doing a one-off consulting project and you can validate that it's working. So there's the details we have versus what we need to start. So now getting into more details on the solution. So I kind of set up what's the problem to be solved, now the solution, and then I'll get into the result. So the solution was very much customer-led, product-driven, designed for the general use case. One of the ways that we were working with our consulting clients, if they were asking for something that wasn't in that 80% Venn diagram circle, we could charge them, but we'd charge them at full rates. Whereas if it was in this, what we deemed as a common case, then we had a much lower price point for that. And then also as we were selling it to the customer, then we would give them a early customer, very heavy discount price. And they would know it's driven very well to their needs. So that's part of the customer-led, product-driven on the enterprise scale. Because we can't data mine without data. So I had to get quite a few different data sets, find out, well, how many of these events do they have a year? How many different sales and promotions? How much do they vary? So there's a lot of questions like that I had to get into. Earlier, I started some Monte Carlo, generating some retail-like data just to set up the process and set up the infrastructure to do the different model training, assuming that later on I would get some data. But that was a helpful exercise at that stage of the project early on. I was very often going through different business interviews. I would have a lot of these retailers or category managers I would be talking to, and I would say, hey, take a look at this. Here's my results. What do you think of this week? And I might get some feedback that, oh, yeah, I guess it's okay, no big deal. And after going through this for about 3 months, one time somebody said, oh my God, that's terrible. You're going to get me fired if you do that. Really? What is this? I've been asking you these questions all the time, but by showing them something, they could point out saying, this is horrible. And so what was so horrible was if you can have two kinds of error, not enough stock or overstock. Well, if you have too much overstock, you get into territory where, well, let's say you have expensive items like flat screen TVs. So a lot of overstock means at the end of the season or a month later, you might have to sell all the items off at a 30% off sale. And so it gets to be very costly. And so if there's certain things that would get a category manager into big trouble, then those are things I wanted to penalize my models in the model training, saying, don't do that. That's very, very bad. But it was interesting because I thought I was really, really thorough the first month with all my questions, but just there's a lot of validity of showing the incremental ongoing results and getting the feedback. And also kind of understanding, what's the best alternative, to a new system. So what are they doing now? So we need to focus on what's an incremental improvement over what they're doing now. And that's not just all model accuracy, but it's in process and workflow. How do we support employee X in doing their job that would be using this? So some of the event attributes. So there would be pricing and also placement. Where are they on the page? What page number? Products, what departments, the layout, and also the store features. So sometimes if a store has like a drive-through to pick up prescription medicine or a camera department, so there would be different attributes where stores could change on a layout by layout. If they're in an urban location, they may be a much, much smaller square footage. They might have a much smaller assortment than in other places. And that would affect a lot the results of the layout because there would be fewer items to sell. So they might not offer as many drinks, for example. And a big variation is the past flyers. So I'm training on the past sales of these past flyers. And so some of them may be 1 page, 8, 12, 16 pages, 20. There was even a few that were 64 pages. And so then there was a couple of questions. What do? I have a current flyer that's being planned 3 weeks from now. Most common, like 90%, were about 16 pages. But then how do I select past flyers that are most like this to use for my training set? And so, like any good scientist, I did hypothesis test. I tried, well, let's just do some kind of fuzzy match, like almost like a cluster Euclidean distance based on the attributes of the flyers. And I got some intermediate results. I tried some other things like have a very specific category match to, okay, this week we're selling on the category of beverages and office supplies. So go back to all the past promotions, not using an entire promotion, but just using if they had a page on that category, on drinks. And then go back through all the past promotions and if they had past sales on office supplies. And so over the past, that worked out much better because I didn't have to have everything locked in the same configuration. So I could do it at a much more granular level, at the category level or subcategory level, at the level of those boxes on the flyer. So it's almost like I was saying, here's my current box, regardless of the pricing discount or location, let's just go through all of the past sales, and I'll use that for training data. Yes?
So did you have the SKU and the promotion code, and you said that was the reason why you saw the up or down, or there's some other piece that could have caused the blip in the sale?
Yeah, so we would know the promotion, we would know what was being sold, and we could look at like prior weekends to see what baseline sales would be. And so one of the things when I took some work just to create the target field. Normally you just have an attrition or future spending, something that's already pops out. But here it took some work because I had to figure out how do I define a baseline spending. If the promotion is 3 days on a weekend or 4 days on a weekend, then I would have to go to past weekends and look at what the baseline sales were so I could see for that past promotion how much higher it was for that category. And so I would do that. I ended up trying SKU, but that got to be too specific and not enough match, but subcategory ended up working well. So I could use that. So there was a lot of interesting exploration, hypothesis testing to see what's the right way just to select the training set.
Quick question.
Yes.
In terms of the effect of the different types of things like page placement and timing and all of these things, presumably you're assembling it all together with some sort of a multiplicative model?
Not necessarily. What I did is I looked at past rates. So by the features independently of the others as step one. And so if I did an independent feature of, okay, of all the items that are on page one, what's their average lift across all 50 past promotions in the year? And then the back page and the centerfold pages and the leftover pages. And so I would come up with some individual attributes and calculate the average of my target, which in this case was lift, how much did sales increase? And then the same thing by page placement. You know, if it was on the top right corner. So I didn't want to guess how much better one thing or another was. I could just observe it empirically in the data.
Yeah, actually, that's what I meant. Yeah.
Yeah.
Yeah. Okay.
And so then there's starting all of that independently, and then I started doing things with combinations. Given a Bayesian prior of its X, you know, a high percentage discount, and it's on the front page, that interaction gets to be much more than additive. It can go way up, and I could observe that. And then that would be part of my lookup tables in the pre-processing. So I could have a lot of different interactions on things. Yes?
So was the discount something that was visible and perceived, or was it
Yes.
So it was advertised as a discount?
Yeah, it could be like buy one, get one. So I convert that numerically to 50% off, just as a rough approximation. Or it might say 20% off, or it might say, you know, spend over 50 bucks and you get $10 off.
But it wasn't based on just the fact that the price, if you compare it to somewhere else, was lower. It wasn't based on an actual economic evaluation.
Well, it was based on they had standard pricing in the database.
Yes, but I'm saying for the consumer, you're testing against the consumer level.
Right, right. Yeah, there was no testing against what other stores have for prices or anything like that. Or it wasn't like any comparison with, say, prices at, some big box.
So the relative pricing wasn't considered just the marginal pricing, so to speak, the perception of benefit in the advertising as opposed to, it's almost like it was a closed.
Well, I treated it much more as a closed system, at least for the phase 1 release first of the product type of thing, just to see how, because we're perturbing the system in different ways. We have a standard system, and then we can perturb it by decreasing price one way or another way. And then I could also try not just by the percentage discount, but gee, does a 50% buy one, get one work better? Or does just a straight 50% off sale work better? So there's things that could be tested.
Right, but what's we're testing with real data and sales, we have other competitors that are doing different things too. So.
Yeah, absolutely. Yeah, and so that gets into use the data that you have available, or at least in the first version, use what you have. Yes?
Did you class the stores themselves in some kind of groups like neighborhood or same size or same demographic?
We did use lat long. We had the zip codes of the stores, and then we had the U.S. Census Demographics around the stores. And so there'd be about 350 fields of the census demographics. So 10 fields might be what percentage of the population in this block group, 1 to 300 households, would have an income between 50,000 and 75,000. What percent between 76 and 100,000? And they would have all these bins, like 10 different bins. And so I could do a lot of things with like a principal components analysis and then feed some of those in. And then for some models it might help, for other models it might not. But it would be offered to the model and that would be part of the system. So when we have store attributes, that would be part of the store attributes. What is the population that lives around it like, based on what we had available in the census? So yeah, very good question. I hadn't brought that up yet. Okay, so something that's probably very familiar to people that have been working in data mining. So just selecting the data for the data analysis, going through the exploratory data analysis. So the EDA stage, I was trying to do that up front myself a lot to figure out a lot of different things. In the pre-processing, I was doing that a lot up front. And I was using the metadata tags in order to implement some of the pre-processing. And there would be, then it got into model building and model evaluation. So as far as building a variety of models and using a variety of different algorithms. And then there was also a lot of post-processing of the score to convert it to business value. So I might produce a lift, but I also might have something that's a lift adjusted for the dollar value. So I ended up having my model train one kind of predictive field, but then having to convert that back to lift. And then that helped me maintain the business focus. Remember, I was talking about don't have too many big screen TVs. And so if you have an overstock or understock, it's also an overstock dollars. That's a pain point. Because if you are overstocked by 50 pencils or 50 flat screen TVs, it's a very different business pain point. So going through the full process of automating the model building and evaluation, the EDA and the pre-processing, there was a lot of automation of just kind of measure, manipulate, measure, manipulate. So talking about selecting the past similar events, I mentioned that a little bit earlier. I was hypothesis test, kind of look at the closest fit of past events to the new event, or compare high-level event attributes, try a fuzzy Euclidean matching, try and select broadly. One of the things I ended up doing is just, if I had a 12-page or 16-page flyer, I would knock out the past 1-page and 64-page. So I would let it be a very broad match for the number of pages, but then get very specific when it got to the product category, going to the past flyers. So I would not use a 1-page flyer that was selling sodas to help me figure out the performance on the 12-page flyer. Or the same thing, I would kick out the 64-page. So I had various levels of what's a broad fit and what's a narrow fit. On pages, it was a very broad fit. On the item categories, it was a very close fit. Yeah, the front cover lift items would have a lift of 5.1 times higher than the average. The highest lift was about 130, but that was right after Halloween and the Halloween candy items. Most of the lifts would be between 5 and 15 or so. The top 5% of the records had 90% of the lift. So if I was looking at, I'm trying to minimize pain, trying to minimize dollars overstocked and dollars understocked, then out of all my records, if I multiply all the items times all the store locations, the top 5% of the records had 90% of the opportunity, the value. So there was a lot of focusing on getting my predictions right for that 5% of the records. So the cash flow, I would call that, would be very concentrated. So if I sort on my score into 20 deciles with an equal number of records in each one, the lift, or my target, it would go up being very high. And so just the range of values was just so huge. Sometimes problems, you might have something that's a very small target, like if you're doing banner ad clicks, it's 3 in 10,000. Here it wasn't that small of a rate, 3 in 10,000, but the value was still very concentrated in that top 5%. And so a lot of the things I was doing were weighting the records, the training records, and and weighting various other things. I was changing the training functions as well. So I was doing a lot of looking at the average pass lift per category, or the target I was working on. The percent off bin, a price savings bin, so that would be the marginal or relative. In the store hierarchy, sometimes there's chains that buy out other chains. And so there's differences that affect that way. And then across a product hierarchy, so I would use a theme of go to the lowest level where I could still have a decent sample size. And so that's a lot of times why I wouldn't get down to the SKU level. I might bump up to the subcategory level. And another thing I've learned from past projects, if you are doing a banking project and you reject somebody from credit, by law you have to give up to 4 reason codes describing for the record, for Ed, sorry to pick on you, these are the 4 reasons why I'm rejecting you for a loan. Well, the same process to figure that out would be very useful in describing to the retailer, this is why I think this lift is going to be relatively high, like 20 to 25. So here's some of the reasons for that. And that would be in terms of the training data and the training fields and ranges. We would handle seasonality because we would be using relatively local data, from within the last few weeks types of things. And also a lot of multivariate combinations frequently became in the top 10 variables. So looking at, say, the price bin plus the interacting with the page location bin, interacting with the subcategory would be an example of a very powerful variable. So for these multivariate combinations, this is something that I've used an awful lot, and it's gotten me quite a ways. I would use bin continuous variables and capture the interactions, calculate the average of the lift, and use them like mini OLAP tables, 3, 4 dimensions. And then it's kind of like a Bayesian prior. Then this can take into account, given these particular factors, the interaction, then what's the past observed lift. And so that's been a very general method I've found useful. So this was showing some of the pre-processing interactions. All I can say is imagine a complex surface here. When I was talking about the dependent by category, those 3-way interactions, it was not just a ridge horizontally or a ridge vertically, but during the 3-way interactions, there was a lot of very different behavior. And I would try and validate some of this by talking to some of the category buyers and say, well, how about this? Does this change if we drop the price from here to here? Does this change and the amount of sales makes sense. So I did some reality checks and I did validate. So as far as doing the training of the models and automating that, I normally manually, I go through a process I call the model notebook. And let's see, yeah. So I'll have one row per record, where a record is a particular model with a particular set of training parameters and specific input data. I would have some input columns, kind of like the data version, the different model parameters, output columns that are kind of like the training time, the results in sample, out of sample, and I would use this gap penalized results because I would want to make sure things are very general, especially since there's no data mining consultant shipping with it to review things. So say if one particular model had, let's see, okay, like here. So here, a regression, the target was lift on a logarithmic scale because it was so extreme. Sometimes a log scale would work better. The regression selected 58 variables. My in-sample results, so the mean absolute error, smaller would be better. So in-sample 1.1 versus 1.2 out of sample, it would have a small gap. And that's something that would, the gap penalized result here would be fairly decent. Some of these others have a very big gap, like 0.9. So it's not generalizing very well when you see different data or new data. And so then I'm not trusting the model very much. So here it's a metric that's balancing both accuracy and generalization. So it is a heuristic, but it's one way of trying to not go all the way to one extreme or all the way to the other extreme. And then for these different things, I would go through this process, trying with, say, stepwise regression, naive Bayes, cubist, neural net, a variety of different things. That would be happening behind the scenes. So cubist from Ross Quinlan, he would have a decision tree, but then at the leaves, since we're predicting a continuous number, the lift ratio, the records in each leaf then would be a stepwise regression. And so then that regression would be forecasting within these, then what the final output is. So it would be, in this case, I have 4 leaves, I'd have 4 different training sets to train 4 different regressions. And so Quinlan was using this greedy algorithm as opposed to what's normal in a standard stepwise regression algorithm. And we were comparing that, his greedy algorithm versus a standard stepwise, and we ended up just going with the standard stepwise because it validated much better, and it's also something that other people have found much better. We were licensing Ross Quinlan's code for that particular algorithm. So here's a training priority. Remember, I was saying the top 5% had 90% of the value. So I'm looking at cash flow. So higher values here would have the number of store items times the event lift, and that would be the non-event cash flow. And so this complex surface just shows how there's different data subsets that I'm focusing on much more so than others for doing the training. So on this left axis is the lift, things with, there was also items that had a lift lower than 1 because you're promoting some things with a heavy discount. Other categories might sell less than average, so not every lift was above 1. Yes?
Last diagram. So in purple you have less lift, and that purple. Oh yeah, I was just saying the mean of the high purple bar graph with the less lift.
Yeah.
Go all the way. Is that a high cash flow value that it's up to 140 or beyond? So bar graph goes off the edge.
Yeah. So this was cash flow of particular items that would be $6 up to $8. So this is $7,647. So it's a high-priced item. Even though the lift was going below 1, my weight on it was very high because there was a lot of cash flow there. And if I get it wrong, there's a lot of pain. So think of a higher bar, if I mess up, is more likely to get me fired.
So this is with lift, so that's not before, that's not the previous, the current state?
Well, this is when I was looking at how I would weight the specific variables. And so this is creating a weight variable based on past lift of the item. Yeah, not the current model. But because sales that are kind of weak, it's about the same or twice as much, you don't have to worry so much about.
So it's based on sales data, but presumably the lift is a comparison of two different sales periods, one before the other, to show change, incremental change.
Yes, that was part of the complexity of creating the target field. You know, I'd have to figure out what's the exact day of week pattern of my future event. Is it Thursday, Friday, Saturday, Sunday? And then I'd have to find previous Thursday, Friday, Saturday, Sundays for each subcategory. And then I would have a baseline sales as a ratio to the sales event.
Right, so the lift figure is based upon a previous delta calculation, but then you're looking at the current sales that might be impacted and change that lift with another campaign.
Yeah, and so, yes, and there would also be like a variety of past sales. So the particular item, one time, may have been here in one past event, another past event, it may be over here. And so it's just weighting the past training records.
Right, okay, thanks.
So, and then getting to some of the reasons as far as what was driving it. You know, if it's in the top 6 of the most expensive items, and surprisingly, that would be like $5.30. So a lot of low-priced items is what's typical in these flyers. Looking at past lift by a combination of store, sub-department, department, and if it was on the front page or not. Average daily sales per item over prior events. So these are some of the most predictive variables that were going into it. And so this is a very important takeaway was the cost of the business pain. And this gets back to when I was talking to the customers. So if I have no error, then that would be here. If I have a cost of overstock, that's going to your right, and understock is going to your left. And so if you are understock, let's say the item's not on the shelf, you can't sell it, so then the pain point might be 15%. Think of that as your profit margin, or profit margin plus a customer annoyance factor, something like that you're trying to penalize the model for. If you have a few extra items on the shelf, then the pain point might be very small, maybe 1%. If I have a few extra things on the shelf, that doesn't matter so much. And so when I was beginning my modeling, I was using these weights of a type 1 error versus type 2 error. So equal mistakes by the same dollar amount would have a very different business pain. And then that epiphany, when I got into the project a number of months and somebody says, don't do this, it'll get you fired. The example with the widescreen TVs. So that's all of a sudden where we get to the knee and that 30% business pain point. And that could also come, somebody might say, well, why don't you just ship it from store A to store B where it's needed? Well, if you move things in a generally empty truck, that still has a huge impact on the cost or the profit of the items. So whether you move it from store to store, you move it back to the warehouse, you put it on a 30 or 40% discount sale, and whatever you do in the retail world, there ends up being a lot of pain. And so the knee of that pain, they were saying, is like a 4-week supply of that particular SKU. If you start getting past a 4-week supply, oversupply, then you start ramping up rapidly in this business pain. And so at first I was selecting models using this metric, and then later on I was getting into the algorithms changing, because it's easy in most algorithms to have a type 1 versus type 2 error or a confusion cost-profit matrix. But here, on a record-by-record basis, this error function would be different. When it was getting into calculating the neural net, when it was backpropagating, the error being backpropagated would go through a calculation of this function. And so this got me from about a 10% reduction in sales in understock or overstock pain to a 30%. Just this, recognizing this, and then changing how the algorithms were trained. So this was huge. So think in terms of a business simulation. Don't think in terms of pulling a model off the shelf and using whatever math happens to be in there. So that had a very big effect. And then also I could show various retailers, category managers, and they were much more in line with the type of errors I would show up when errors did occur. So yeah, I talked about changing the error functions, and like in the same thing in a stepwise regression or in the cubist leaf regression. So now worrying about response time. So we can do lots of training, but if it takes forever and people don't want to use it, it doesn't matter how fancy your algorithms are. So we had to balance, we need something that would be very reliable at a simple step, but then more training time could get much more sophisticated, better in accuracy. So what we ended up coming up with as a compromise is a 1 to 5 button. Button 1 is the simplest complexity. Button 5 is the most complexity and takes the most training time. I wouldn't tell them what's going on behind the scenes. They didn't care and didn't want to know, and I didn't want to have to explain it anyways. So level 1 would be something like maybe train half a dozen regressions with some various things changed, maybe some smaller decision trees. Level 2 might be like that, plus trying some other things that are getting more complex and more complex, up to button 5, which might be training 30 or 40 models and trying some model averaging, boosting, and bagging types of things. So level 1, the first level button might be trained in about a minute or two, and then the most extreme training would be 2-3 hours, given all the things going on in the background across all the different CPUs. But we had to make sure at that level 1 was a big concern, because if we ship the project to Victoria's Secret and that particular category manager just always uses level 1, we had to think, if we're installing this enterprise software product into 100 different retailers, what's the worst case? We have to worry about that worst case, because that's going to be our product reputation. And so that's why I was trying to have a variety of simpler models. And that's why I was trying to have some of that gap penalized metric. So I'm very much focused on what can be general. And I mentioned it's software, not consulting, because we were doing the configuration. Okay. And so talking about the reduction in business pain dollars. So I would have a particular store item combination. If we had ELF overstock, or if it was understock. And then I would also have a separate metric I would be reporting and looking at very closely. If it was high overstock, that would be like over the 4 weeks overstock. And so then this ended up being, since I was doing this in a consulting project, then I had a working system. I was a mere marketing guy, product management, so I had a working system. I could turn it over to the software engineers. They were integrating it with the database, doing the database design and some of the GUI design. But we had a working example. If they wanted to change some specs a little bit, that can be okay, but it still has to meet this minimum level of functionality. And then that was definitely going through a lot of Agile and Scrum iterations, working with them. But we had the test data I could turn over to them for regression testing and various other types of things. Filed a provisional patent, so I found out a little bit about that. So we had some help from a patent attorney, and we're going through that formal process. Found out about ordinary skill in the art. So the types of things you can patent are things that might not be obvious to a person who have typical skill, say in the data mining or in database or in software development. So the idea must be novel, non-obvious, and useful. So novel, not appearing in the previous literature, non-obvious, not necessarily easy to be discovered. So That's some other background on this. Other verticals that it could apply to, if you were getting into marketing, advertising, if you had different kind of price discounts or promotions, if you were trying to cross-sell, upsell, send people other kinds of things. So just as a summary, some key points of the project were figuring out how do we automate this, and that was kind of from the center out, kind of in the onion. If the onion is the KDD process. So first automate the model building and training, and then automate some of the pre-processing and EDA, and then build out to the GUI and the user interface. How to select the training data. So parts of it were broadly selected in terms of the number of pages. Other things were very narrowly selected based on the SKUs. The best improvement had to do with being very, very focused on the business metric. Understand very clearly what gets people promoted or fired, and having that drive the optimization function of your models. Very important on figuring out how to make it robust. And also we could support but not require a lot of fields. So if somebody else, like we take it to Europe and there's no census data because of security laws, then the census data wouldn't cause the whole system to break. We can use things if it's available. If it's not available, then it's not a problem. So there's a lot of metadata selection. Select the available fields, select the populated fields. And if they're populated fields of this metadata type, then you preprocess them this way. So how to succeed in building enterprise software. So support end users at the level of complexity they want. So it's not like talking down to people, it's just talking at the level of detail they care about. I would always think of, hey, my dad's an English teacher. He doesn't know anything about data mining, but he can speak classical Greek and Latin, stuff I can't even touch. If I talk to him and say, he says, hey, Greg, what are you doing today? I give him an answer at a certain level of detail. It's less detail is not less respect. It's just a matter of what's the appropriate level of detail that's of interest. So the same thing with job function and supporting people to be better at their job. So questions, answers? Or no, time for Q&A. Yes?
The system you described, did the approach result in the system that turned out to be quite durable, or do you think did it require maintenance and you did it, or it changed it needed to change over time?
System was durable over time. Installed for other clients, and there was the expected install and configure, but not install and do data mining projects. So that was the target objective of the design. So, other questions? Yes?
So for your data, right? So do you do pre-training and then kind of like have some pre-trained model, and then when you install in the store, and this is just my guess, right? So the store manager will, based on whatever, this time I put the promotion and input the data, and this is what I predicted the system predicted to be, and then next time I relay how much I sold, and then feed into your model, and then your model will learn that, and next time, so it's like
a little bit like that. When the project was shipped, there were no trained models. So part of the install and configuration process is load the last year's worth of events, of sales events. Okay, and then by loading the past years of events and then training the first model as where our consultants are the first users, kind of like they're in the driver's seat and the client is in the passenger seat watching very closely what's going on. And then we train it for the first promotion, and that goes through all the process of the model and model review. Then it would be the next time the client would be in the driver's seat and our install consultant would be in the passenger seat, and it would kind of go forward from there where the clients would be independent. But there was no models shipped with the product. It was just based on their specific training data.
Yeah, but in your one of the things you have a lot of parameters you want to twist, right? Like you mentioned about you need to like FAR, FRRs, type 1, type 2, and also based on some certain situations you may want to twist those parameters. Do you also, I suspect that will be different from one store to another and from one time item to another and from one situation to another, right?
That would be covered by the design of experiments. That's what made it robust. One of the things that made it robust. So that what would work well for promoting, for training a model on one kind of event at one kind of retail chain might be different than another, but I'm trying out a variety of different methods of pre-processing the target, a variety of methods of weighting which records are most important. Not just, changing parameters on, say, a decision tree or neural net, but there's also a lot of system parameters to try out to see what is best in this exact situation. And so for one particular model, it could be a decision tree with a logarithmic scale on the target, then converted back to a regular scale before it goes into the next system. But so you're right in observing that what works best in one scenario are going to be very different from another. And the solution to that was build that in part of the hypothesis testing framework, the scientific method. So they hit button 1, and there's all sorts of scientific experiments going on behind the scenes that they don't need to know about.
So I suspect when you have the parameter input for each item, you probably have item price, size, weight, shape, all those things, right?
Yeah, now one thing we didn't get into that was a later stage would be attributes by category. So there's certain flavor attributes that you could get on yogurt that you're never going to get on pants. Okay, and so that's a whole nother ball of wax of what are the category specific attributes. But then how are we going to get that across hundreds of different retailers, from Home Depot to food to clothes to books? And so that was something that we didn't do in the initial stage, but that was something that that was on the list that if customers were asking for, we had some answers.
Thank you very much.
Sure, thank you. So, other questions? Yes.
Just two quick questions. One is, how did you record if the if a customer came to the store and wanted to buy something and the store didn't have, how did you record that simply? And also, how good was your model at the end?
Sure. So if the customer came to the store and they didn't have the item and they just walked out, so for that, like the out of stock pane, that's data we didn't have. The best we could estimate was how long were they out of stock. And so if there was a 4-day sales event and the past training data had just items on the Thursday, but not the other days, then when you go back and you look at the other baseline levels, you could see what's the ratio of sales on a Thursday to a Friday, a Saturday, Sunday. And so you could look at, that's like lost opportunity. But realistically, I had enough data. If there was like out of stock situations in my trying to get my baseline, I would just throw it away and not use that past weekend. But usually I wouldn't get that in the baseline sales. But if I had a past sale that was like, say, 4 weeks ago, where on the weekend, some of it, there was very much of it that looked like it was out of stock, I might just throw that one out as a dirty data point. As far as how well it did, then some of the results were, the metric they were using is minimize dollars in overstock and minimize dollars in understock. Okay, and so if you take that and add that up to a year, then we reduce that by 30%. So it depends on the retailer size, but it could easily be 5, 10 million. So if we try and sell our software product for 1 or 2 million, and there's 1 or 2 million of install config stuff, then it easily pays for itself. So, and we could run through some worksheet estimations, like tell me what's a typical price of your product, what's a typical price discount kind of thing. So
that was kind of my question. What was the ROI of the benefits to the customer versus the cost of the service.
Yeah, I mean, it would vary for some. It's hard because once something is installed, then a lot of times the people using your software don't necessarily came back to us and say, you saved us $30 million this year. So we don't get the direct feedback. Some of the things that we could estimate, were that 30% reduction. So if we could find out, gee, what's your total overstock, understock, then we could estimate that as a reduction of, say, 20 to 30% conservatively.
Yeah, it's interesting because.
And then look at that as an ROI to the total cost of ownership. I'm sorry, go ahead.
No, it's just that most of the, let's say, the e-commerce web advertising campaigns are directly measurable.
Yeah.
Because they didn't happen.
Oh yeah, no, these would be measurable, but not necessarily that the clients reported back to us. So in the system, then what we could do is find out how profitable was the sale. And one of the things that was an interesting takeaway was when we were talking with some of the business people, they were saying, oh, now I can do what if scenarios. Maybe now that you built this model for my sale 3 weeks from now, maybe I'll try my different layouts with a different percentage discount or different items.
So part of the problem is that the printed campaigns are not printable. So in other words, you cannot get a more direct detection of when they were actually acted on. And so have you taken this technique towards the online ads as well?
Personally, I haven't, no, but some of the techniques I have, like the variable interactions type of things. I definitely use that broadly. So, but I mean, I think part of your question I misinterpreted. I was interpreting what's the ROI of the overall company paying for our product. And I think later on from what you were talking about, it sounds like the ROI of the individual sales event. Is that what you meant?
It was both.
Okay. So for the sales event, yes, we definitely had information tracking what's the profitability of the sales event, because we'd have to look at what's the total dollars discounted, and they have budgets for that, compared to the additional incremental revenue brought in. So yes, there was definitely reporting for that. Yes?
If you were to redo this today, using all of the latest available computer hardware, machine learning algorithms, and assuming you had all of the data of all of the retailers, what, if anything, would you do differently now?
Definitely get more compute intensive. I wouldn't be nearly as shy. I would much rather have a lot more exploration, design of experiments. The initial phase one of the design of experiments in the first button were much more fixed. And then after that, it got to be kind of a particular heuristic. How do you search through the different parameter spaces? And so doing larger growth there. Another thing would be maybe looking at optimizing. So if I could generate one model representing the expectations of this campaign, then one of the things that they saw very useful is just try slightly reconfiguring the flyer layout. Well, rather than having a human reconfigure a layout, it's an operations research problem. And the objective function is the model prediction. So you can almost have this layout of the event be an operations research problem that you optimize. So rather than having a category planner guess, maybe I'll put this on the front page today and and something else in the middle, then we can offer some suggestions and some estimated value. So that might be another area. So.
Just along those lines a little bit, a couple of things. One is, did you experiment with like a deeper neural network or something with hidden layers and that sort of thing? If you did, to what extent would that preclude you, or rather, would that let you avoid having to do so much feature engineering?
I don't think I would cut back on my feature engineering. This was finished in 2008, so yeah. So that would probably be another thing I would want to try now is some of the deep learning nets. But I'm very empirical, so I would just have it try out a deep net, maybe 5 hidden layers or something, against some of the other methods like gradient boosting and just be empirical to see what works out. And part of it is balancing cost of, gee, if I can train 20 models of a low CPU basis versus 1 or 2 models of that take this much CPU resource. If I'm trying to be at all constrained by that or aware of that, then that's another balancing factor. So maybe I can train lots of other stuff and then but try 1 or 2 deep nets.
Right. And then also, so at the end of the day, would you be able to produce the optimal flyer that is profit optimized, I suppose, to some extent, right?
Yeah, I mean, that's
one solution in theory, right?
Right, yeah, and that's what I was saying to the earlier question, would be, as opposed to having the retailer kind of guess, well, what % discount should I put the soda, what % discount should I put the candy or greeting cards, then have a program that optimizes all of those parameters and does, maybe explores hundreds of different layouts. And then we already have the objective function. When you do an operations research problem, you have to evaluate what's the effectiveness of each one. And then we would have the trained model, that would be the objective function. So then score the layout of this particular thing. And that's, you could do that if you weren't changing, say, the products. I mean, if you had something that had, you went from no Christmas wrapping paper to Christmas wrapping and Christmas decoration items, you'd want to retrain. But I mean, if you're in the same realm of products.
Seasonality and things like that, of course.
Right.
So you did mention that you were trying to do a product as opposed to consulting, right?
Yes.
So when you now approach a competitor in the same vertical, you have pretty much deep knowledge of the first guy that you used. And when you're trying to sell to the competitor, you are pretty much, you both are having the same kind of solution. Now, there is no competitor advantage between them in some way.
No, no, there's their data. So it's just like 2 accounting firms can buy Excel. That's not saying accounting firm A doesn't have any competitive advantage over accounting firm B. There's going to be a lot of other value add that they specialize, it's their domain expertise. And so this was very much along those lines, is we're trying to help people in their job function be more effective. We weren't trying to replace a job with an artificial intelligence. It's all about complementing people and helping them be more effective. And to the extent that the combination of the person and the software is better, then we would be more successful.
No, but what I'm saying is the competitor also has a similar product, right? I mean, what the 2 guys that they're using, you are giving some recommendations to them from your experience with the first guy. So they're pretty much under.
Well, no. I would sell this to Walgreens. Okay. Use Walgreens training data for past events. If we talk to CVS, then CVS would use the CVS past events, the CVS SKUs, the items, and how they promote things, and their zip code distribution, and their, all their other types of things. And so there's, so companies would be, all using their own data. But again, JDA has 50 such projects, or enterprise products. So like you could say the same thing about the replenishment product. Well, if these 2 companies both have the replenishment product, then are the companies no longer, are they just equal? No, there's still a lot of differentiation. There's a lot of value add. There's a lot of different processes.
So at some point, the guys who are in the shop trying to get the data have to maintain their integrity, not to share information from Walgreens to CVS.
Yeah, there's no sharing between.
What I meant is the consultants who are there on site, not sharing any knowledge that they have from Walgreens to CVS as to recommending. Not from the engine point of view, but saying, I think Walgreens does it like that, you might also be able to do.
Yeah, so there's nothing like that. Anything like that would be kind of in the design of experiments. Okay, here we're going to try out, these 10 approaches. And so some of the approaches might work better for CVS stationery. A similar approach might not work out best for Walgreens stationery, but maybe it'll work out best for Walgreens, art department, or I'm just making up some other category. So things will be very, very different as far as what evaluates to the best. And it's very much based on the training data. So thanks for your interest. I'm definitely glad to answer all the questions.